Hello, welcome back to ITBS Media. Your host on this channel is Dr. Adenuga. This is day one of our series on API security, and I'll be explaining API vulnerabilities and penetration testing will follow. So, what I'm focusing on today is explaining what APIs are and what API vulnerabilities are, what API security should look like, and I request that you join me tomorrow in the continuation of this series, where we'll be going to the lab and doing the demonstration testing for API vulnerabilities. So you need the foundation so that you can understand what goes on in the lab when we start sending commands and we start receiving and analyzing the commands. So if you already have a basic knowledge of what API is, how API functions, what API security should look like, and what API vulnerabilities are, then you'll be able to get enough knowledge from the lab demonstration. That is why this particular lesson is a prerequisite for what is going to come up tomorrow. Okay? All right, let's go into the next. So what exactly are APIs? An API is an application programming interface. It's like a bridge that lets apps, devices, and websites to communicate. So when you send a request to the server or to an application, the request has to be transported and delivered to the endpoint that, or the server that will process the request and send back the response. So the API stands as a go-between between the source request, the request point, and the response point in our network communication. Let's look at it this way. Think of an API like a waiter at a restaurant. You tell the waiter what you want, but you know that the waiter is not the one that will prepare the food. The function of the waiter is to get the order from you, take it to the kitchen, and the food will be processed in the kitchen. The waiter gets the food in the kitchen that has been prepared based on your menu specification, your selection, and it brings the food back to you. You say thank you to the waiter. You did not see the caterers that are working in the kitchen. You do not have direct contact with them. Same thing happens when you make a web request or an application request. Okay? You do not interact directly with the server. Rather, you interact with the API that takes the request to the server and return the response from the server. So it's a transporter of request and a conveyor of the response. So apps work that same way. That have the scenario I've created about you visiting a restaurant. That's the way apps work. So your phone, your web browser, your smartphone, your home devices, they all use APIs. And what do they use API for? To fetch data that you request. So they send command and they interact with services behind the scene, which you will not see. But Those are the ones that they interact with, and they fetch you the data that you actually requested. So we move on to why APIs, why they matter, and why you need to understand or have a knowledge of what APIs are and how they should be secured. So if you are in cybersecurity or you are a developer, obviously you need this knowledge. You are auditor, you need this knowledge. Risk professional, you need this knowledge. You must understand how API works to be able to set in place controls, whether you are a security architect or even a security leader. You need the knowledge to be able to protect the assets within your purview. All right. So almost every modern systems depend on APIs for communication. I've mentioned mobile apps. The banking systems use APIs because sometimes they need to fetch information even outside of the banking system network. For example, let me give you a scenario. You applied for a loan from a bank, and the bank want to run your credit check. The bank is not in possession of your credit score. The bank will have to contact one of the major credit bureau, and because of that, they need API to run between the bank and the credit bureau to fetch your credit detail, with which the bank will now be able to make informed decision about your lending and paying habits and determine whether to grant you the loan or not, and also whether to provide you loan with a lower rate or with a higher rate based on the perceived risk. So that's how it goes. Your e-commerce platforms also, they use APIs. Some e-commerce platforms provide API connectivity with their sellers. So the sellers have a link. So from the seller portal or backend, the list of items to be sold on the e-commerce platform is pulled electronically from the seller's network. So you see how API connects the world, helping to send a request and returning response. So your social media also, the social media accounts, you fetch data from different parts of the world through your social media account, and it is the function of the API is to run the errands and bring you the results. The cloud services are another area where API usage is very significant. Then you have your IoT devices, the Internet of Things devices. They all use APIs. So that makes APIs extremely powerful and useful in our modern day communication. So because it is useful, it is available, or it runs in most systems and network, that makes it to become a target for attackers. And if it's now a target for attackers, it means you also, as a security professional or a technology person who is developing an app, you need deep understanding of this and how to make sure that you develop your API in such a way that it will not leak data. So let's proceed to API security. How attackers exploit weakness in API security. The first thing we're looking at here now is a weak endpoint. A weak endpoint. So a weak endpoint is a dangerous point for security apps. For app security rather. For the application you develop, if the API, because if you develop application, the application will fetch data from different databases across the world. So the API that will run that errand to fetch data when a user prompts or requests a particular set of data, if that API is left vulnerable, then it means the app itself is vulnerable. So these are examples of weak endpoints. When you are able to, like in your browser, you're able to get to the page /admin/debug/vs/users/exports. If a user can have direct access to this kind of pages, then it means that the API is weak and vulnerable. So we move on. Now, another weak point is broken authentication. If the API doesn't properly verify who the user is, then it means that attackers can steal accounts, bypass logins, use stolen tokens, and impersonate real users. So this is one of the most common and damaging API attacks. If it's possible for attacker to modify the URL and access the data of another user, either mere accessing it or even is able to update it, then it means the configuration is faulty, it's weak, and must be corrected. So API must always request for authentication, and when authentication is requested, it means that the credentials that have been stored to identify a user must match the user account when the user wants to access that account. It's just like you want to log in into your banking account. You have to provide your username that points to the page where your detail is stored, and your password must match what has been stored against your account. If it doesn't match, you won't be able to log in. And if you have multi-factor authentication, it means that even after your password, you still have to go ahead and provide additional credential that will identify that you are who you say you are. And that is what is called authentication. So broken authentication is when API does not follow that regular procedure to verify the identity of the user. So the API just pour out data requested without verifying who the assumed user is. That is what's called broken authentication. for example, in URL, you have maybe ID 2 for your account, and you change it to ID 3, and you're able to access the page of another user without putting in that user's username and password. That is obvious demonstration of broken authentication. All right, so move on to the next one. Missing or weak input validation. So attackers send malicious input to the API. So it is possible to send SQL injection, command injection, mass assignment, or IDOR, insecure direct object reference, like the one I've explained earlier. So it is important that the API is configured in such a way that it will not accept just anything from the back end or from the user side. Rather, there are processes that must run only from the back end. If a user inputs such command at the user interface, it should be rejected. There should be error message instantly. But without that, it means there is weak input validation. So the input there is referring to user input, not admin input, user input. So user interface should not accept a user interface. If anything, any program like that exe, meaning that executable command, user interface should not be able to run any executable command. Otherwise, SQL injection will be possible, command injection will be possible. So it is important that as a developer, you ensure that you test your project, your app, to make sure that your API does not accept user to run any executable command. So now, no rate limit. No rate limit is another weakness that API may be susceptible to if it's not well developed, if it's not well configured, not well developed. And what does no rate limit means? It means that that particular application or API does not have a limit on the number of requests that a user can send within a time frame. So what does that leave us with? It opens the door for what is called login brute force attack, where the user can run maybe a list of credentials, password, and username, maybe gotten from dark web and things like that, can run it against that particular application to see if there will be any match. But if the application or the API has been configured to reject any attempts to log in, once there is wrong inputs 3 times or 4 times, it means that such password attack will not be possible, because once the first 3 runs and it's wrong, the system will lock for a period of time. You can say you can only return after 24 hours, or you can only return after 30 minutes. So that prevents login brute force attack. Then scraping the entire database will be possible if there is no limit to the volume of data that can be requested by user at any point in time. Then denial of service. Denial of service is possible if there is no request limit. It means that the attacker can send, through the user interface, can send a lot of packets to flood the traffic so that the application or the API will not be able to access other services, thereby denying other users the access to that application or the API. So these are some of the weaknesses that are common to APIs and applications, and which developers must take notes, and also for which cybersecurity professionals, cybersecurity analysts, security and IT auditors must look out for. All right. So now let's go into, we've seen what weaknesses could happen. Now let's look at the security. How do we now prevent those from happening? So the first thing is strong authentication. Strong authentication. API must confirm the identity of a user or system before granting access. So for API developers, ensure that you do not just develop API that request no authentication. Authentication, it must be part of your design. It has to be security by design, not afterthoughts. Right from the planning stage, you have to factor security into your API. Then you will give your users, the legitimate users, peace of mind, and they'll be willing to patronize your application or your API. So, and the method you can use is use API keys, auth tokens, JWTs, multi-factor authentication. So these are some of the methods that you can use. Then, input validation. Every request must be cleaned, checked, and verified. So, because validation prevents SQL injection, remember we said it earlier that it is possible for SQL injection to run easily if the user interface can easily run executable commands. But it should be prevented. User interface must not be allowed. The user input side, the user side must not be allowed to run executable command, path traversal, command injection, and business logic abuse. So once there is input validation, the system validates that this is acceptable, this one is not acceptable, and it rejects it. Then it means that the app as well as the API will be more secured. Now, what is coming next? We've talked about what APIs are. We've talked about the weakness that are possible in to come across in APIs. And these weaknesses are not just, they are not there because they must be there. They are there because of maybe inexperience in development of API, or maybe not being careful enough. Maybe, at times, at the initial stage, there could be some of these controls in place. But as modification comes and the app is being updated, is being maybe checked for something, there is every possibility, because it is human that is running these things. So it is possible for the human agents to forget to perform certain critical action, which may now leave the API exposed. And that is why organizations do pen testing, and that's why they run audits at intervals. Because what if something has been broken unintentionally, not even knowing? That is different. Another one is that could be internal compromise. So we have what is called internal threats in organizations, and that's why cybersecurity leads and professionals must always test. They should have a regular testing cadence for things like APIs, applications, and other assets of the organization. So what is coming next? Join me tomorrow by 10 a.m. Eastern Time for lab demonstration of penetration testing of API using vulnerable websites. So you want to be there. Now that you have learned the basics of API, if we're demonstrating how APIs and applications can be maliciously manipulated, you will understand, because you've learned the theoretical aspect of it. Then you can now follow on in the lab demonstration to build a holistic knowledge about what APIs are, how weak they could be, what could be the causes of the weakness, and what is the standard to make sure that they are secured. What is the secure? What should the security of API look like? We have explained all this, and I'll see you in the lab tomorrow at 10 a.m. Eastern Time. Again, your host is Dr. Adenuga. And don't forget to like, subscribe, and join the